this is a brief diagram that summarizes the movement of data from internal ERP systems in various systems that a company might have through the data quality engine, the Informatica IDQ, and data movement. So we'll go through some of the issues that present themselves and manifest themselves in the various systems and how they can be cleansed. We'll go through some dashboards which are specific to the areas which Mo and Stefan identified around perfect order index and metrics. And then we'll show the cleansed data which manifests itself after the cleansing is done through the IDQ engine, and you'll be able to see how it represents in the various dashboards that are used for presenting data to be able to make decisions. So this is a data set that is set for about 27,800 rows. It's raw data summarized by product line items, containing product category name, product category numbers, products that fall within the various categories that are summarized. This is the highest level of the product category. It might contain 2, 3, 4, sometimes even more levels of aggregation. As you can see, this is a fairly medium-sized data set, but it has all the different products that we'll review. The data also contains order line item level dollars aggregated by these categories, and we'll show you in the dashboard how that is represented. The dollar line item level data can be reported weekly, monthly, quarterly, annually in operating reports and used for analytics and decision-making purposes. The product level information can then flow into enterprise systems. So the information that is aggregated at the dollar line item level, which is for these products, and supporting information about these products, can flow into enterprise systems, which include ERP systems and many other systems that will be crucial for companies' operational performance. The information could include SKUs, packet sizing, retail and wholesale pricing as it relates to distributors, resellers, online and other channels, that is then stored in other systems such as product lifecycle management systems, supply chain planning systems, factory planning systems, demand planning systems, CRM, CPQ, warehouse management, inventory management, shipping and label, and freight systems, and the list goes on and on. There might be many internal systems that the data would flow, for these products and the detailed level of products that are below this high level aggregation. That data flows through all these systems that I just mentioned. The product manufacturing information is also a pretty large set that relates to these products that goes through many systems and is used in many systems. So data like make locations, country of origin, percentage of parts that are bought versus manufactured in-house. These are some examples of data that is created, acquired, and cascades through many systems that I mentioned above. Now, the reason I've mentioned this is any poor data quality at the product level for these products would also cascade through these systems. So if the SKU is incorrect, packet size is incorrect, country of origin, labeling, make location, SKUs, which are make or buy spread between the SKUs, and PLMs, the data across PLM systems, all that data would cascade through, and if there's anything incorrect in those systems, it'll cascade through all the systems. Which then, and we come to the point of this entire presentation and webinar, If there are those data quality errors or the detail at which the data is acquired and saved is not accurate, it has actual tangible implications. It could result in orders being shipped incorrectly, so returns, repackaging of orders, relabeling, reissuing of bill of lading and invoices. And all these can delay payments or extend payment terms as it relates to customers not being happy and have to return the orders. They can also result in lost orders, and at the very least cost a lot of money when they require rework by the operations and warehouse staff, by the factory planning, by all the various processes and people that are involved in reshipping, relabeling, repackaging, reissuing bill of lading or invoices, and so on. So the most important piece out of this presentation, and I'm focusing on this list of products, is that the issues, if an order is shipped, the product information or because of any various reasons that I've mentioned, if the order is not accurately shipped out, it is even more important because we'll have to keep excess inventory. It is even more important to actually focus on these issues, because if there are errors and they result in incorrect shipping to the customer and repackaging, as I mentioned earlier, we have to keep excess inventory, and that results in truly not completely fulfilled orders. The excess inventory is really to use as a working capital to repackage, remake, reissue, and reship the orders. The working capital that is locked in this excess inventory then is not a very productive, to say the least, use of that capital. And saving that working capital from excess inventory can actually result in saving interest expense at the very least. And of course, in addition to all the efficiency loss can be prevented. So we're going to demonstrate the metrics that can be used to calculate the true efficiency of order fulfillment and supply chain. We're also going to show the data quality improvement, and I'm going to show you what those data quality improvements that can result in increased transparency of the supply chain and hence result in better fulfillment of orders. This is a dashboard that is created using the data set that I showed earlier. The order line information is this first column is what I was showing earlier as product information. As you can see, this is the exact same product category data set that we had earlier, except that this is the actual dollar amount aggregated by the products. So this first column is the dollar order line information aggregated. The second column is OTIF, which is on-time in-full shipment of orders, which measures efficiency of outbound shipment of orders, but not complete order fulfillment. And I'll just explain that in a minute, what complete order fulfillment means. But before I do that, let me just point out one more thing. There are, in this data set, a few data quality errors. One is, if you look at this water dispenser, there's a product ID that is mentioned 3 times. So there's a water dispenser 1250B, water dispenser 12501, and water dispenser 12511. These are all data quality errors in the data set, which prevents the accurate, even if you have the right metrics, it prevents the accurate portrayal of what those metrics are showing. So as I mentioned earlier, the POI doesn't measure the full efficiency of order fulfillment. It's not a complete order fulfillment efficiency. The perfect order index here is meant to demonstrate that. It illustrates how we measure the complete order outbound shipment of the order and any returns that might happen. So the difference between POI and OTIF, for example, if you take high pressure cleaners here, it's nearly a 10 percentage point difference between OTIF and POI. This difference between the two shows that what was sent out doesn't accurately reflect the efficiency because there are returns. And more importantly, there is working capital that is locked because of this difference that has to be and locked to make the reshipping, relabeling, processing the orders, and sending the orders more accurate. If you see here on the last column, this is the total working capital, and the chart here represents the difference between the POI and the working capital that is consumed because of this. Let me just summarize this a little. So this chart actually displays what part of this working capital. So, for example, in the example we were looking at, the high pressure cleaners, 8.56%. 8.56% in this case of $26 million in working capital is a significant amount. And this chart here is actually about 4.1 million, which is the amount consumed from the working capital due to the inefficient outbound orders and the returns that have to be processed. And if POI is actually measured correctly, then it's at least we know how much can be saved. Now, on the bottom, these are returns. So the bottom right is there are two. The bottom right here is incorrect document processing, and the bottom left is damaged returns. I'll take an example of incorrect document processing first. So in the bottom, you can see that there are 3 areas where the orders were processed because of various reasons, right? So minimum order quantity was incorrect. So for example, if it's a dozen versus just 1, so the order was for 1 dozen, 12 pieces should have been shipped, but only 1 was shipped. This is a hypothetical example. The second is a unit of measure. This is an example where something was in centimeters, but was shipped or manufactured in inches. Now, in this example, it is a significant reprocessing because a larger number of people and processes are affected if the order has to be remanufactured or taken out from the, or if there were a whole batch was incorrectly manufactured, it has to be remanufactured and taken out. The old batch is pretty much a loss. It has to be remanufactured, repackaged, reshipped, relabeled. All those, the entire supply chain is affected. The third one is unknown reason. So this is, we don't even know if there's an error in these orders. They were returned, but we don't know why these returns happened. And that is also significant data quality error, because if you don't know what has to be fixed, you can't fix it. On the right here are damaged returns. So there are some cases where the water, for various reasons, these different within these different product categories, the orders were reshipped or had to be reshipped because they were returned. I would also like to point out a couple of other things. There are nulls here as well as blanks, which are simple data quality errors. Let me switch to Informatica product. This is an IDQ, Informatica data quality screen, where there are some fixes that have been made. And what we did was put the entire data set through IDQ. What you see here is what percentage of, it's a profile. It's what percentage of the product category and product numbers were incorrectly captured. And if you remember from what I had shown earlier, there was a product which had 3 different product numbers, item numbers, 12500B, 12501-1, and 12501. 12501 is obviously the right one. The others one are data quality errors. This shows a histogram, which is charting out all the different errors. And there are a few more here on different products. And it's basically showing the top 5 and how this spreads across those. This screen is from Informatica data quality after corrections are made. So there are after data profiling is done, there are rules that are set in IDQ, and the data can be pushed through. Obviously, this is a very simplistic example of data corrections, but at the bottom you can see that 12501, which was an incorrect part number, has been fixed. And as the data goes through IDQ, and on top here is a separate screen on what those data quality rules were to make the fixes. Let me switch back to our dashboard, and what you see here is a corrected dashboard. So if you see the 12501 is only listed here once, but what it has resulted in is accurate order line, accurate OTIF, and accurate POI. Now, the difference in this case is not very large, it's 4.76%, but that too results in a fairly, it's not a very big, but it's a $19,000 working capital impact. In aggregate, all these pieces, which are differences between OTIF and POI, effectively a percent, if you add up everything as a percentage of working capital, it's a significant amount. The other piece I wanted to show was that the nulls and blanks are removed from here. Now, you can see that the minimum order quantity errors and incorrect unit of measure, those are here. And those are larger errors, which are not just fixed by putting the data through a data quality tool. You can, and that's more of a data integration and cleansing exercise that has to be done at the source system level so that it can cascade down. So for example, if the reason is unknown for why this particular vehicle wash system products were returned, then it has to be added. There might be a screen that somebody is entering as the returns come in. A process has to be improved, or systems have to be modified to make that change. It can also be added downstream where things can be updated as even if it's errors are created in the source system, downstream from the source system, processes can be added, and technically it can be modified so that the dashboard represents exactly why the error was, and somebody can act on it.